Welcome back everyone to this section on joins. So in this section of the course, we're going to discuss the various types of joins that are available to us with PostgreSQL, and really a join at the heart of it just allows us to combine information from multiple tables. And let's take a quick peek at what we're going to learn in this section. We're going to start off this section by quickly discussing the as clause, which is a really useful clause for creating an alias. That is to say, it just allows you to rename a column whatever you want. Once you understand that, we'll move on to joins. So we're going to discuss different kinds of joins, such as inner joins, outer joins, full outer joins, unions, and more. So there's things also like left joins and right outer joins, etc. So lots of stuff to discuss here. We're going to start off with the simpler join types and then move on to the harder to understand or more complex join types. But overall, once you understand one type of join, the mental leaps required to understand the other types of joins isn't too bad. Okay, and then we'll end this with some challenge tasks. All right, so now that we understand what we're going to learn in this section, let's move on to the next lecture. I'll see you there. Welcome back everyone to this lecture on the as clause. Before we learn about joins, let's quickly cover this as clause or as statement, which allows us to create an alias for a column or result. And what we mean by alias is just an alternative name. Let's see the example syntax for this. This is actually quite simple. Instead of just selecting a column from a table, we say select column as, and then we decide on a new name to display in the data output. We can also use this on functions on a column. So we can say something like select column and then have that, instead of displaying as sum of that column in the data output, instead have it display as new name. Let's see some examples. So this is the way it classically works, where we say select customer ID from payment. And notice that the column name is the same in the data output below. We see customer underscore ID. Now let's see what happens if we were to use the as statement. So here we're saying select amount as rental price from payment. So notice here, instead of having the output reported as the amount column, instead we decided to give it an alias or rename it as rental underscore price. And maybe this will be easier for some other analysts to read when we actually show them our SQL query results. So really here, it's just for readability on the data output. And this starts to make sense, especially when we perform functions on a column. For example, select sum amount as net revenue from payment. And instead of having the output just say sum of the amount, here we can clarify it with an alias as the total net revenue from the payment table. So essentially, in net revenue, we've made around $61,312. Now keep in mind, the as operator gets executed at the very end of a query. And this is where a lot of students, especially beginners, get confused. That means that we cannot use the alias inside of something like a where operator or a group by call. And I'm going to walk through an example of trying to do that and having it show an error, because a lot of students get confused on that particular notion. You essentially only get to use that alias in the select statement. Anywhere else, it's not actually going to be valid. So let's head over to pgadmin and walk through an example of that. Okay, here I am at my query editor. What I'm going to do is say select, and we're actually going to say count the amount from the payment column. So if I run this, notice I get back just count as my output. And if I just see this data output without any regards to the query, it's pretty unclear what this is actually counting. So maybe I want to clarify this using an alias. So I can say as, and counting the amount from the payment column is the same as asking how many transactions have occurred. So I can say number of transactions, run this, and now I see that the data output has been renamed to be num underscore transactions. And recall, with count, you can always just pass in anything here, such as an asterisk, and that will be the exact same thing. So here, saying count asterisk as num transactions from payment, using this alias, it makes it quite clear what the data output is actually showing us. Okay. Now let's imagine we were going to do a group by statement. So let's do the following. Let's say select the customer ID and then sum amount from payments, and then I'm going to group by customer ID, essentially showing how much each customer actually has spent. So I run this, and I get back the customer ID as well as some sum. However, if I'm looking at the data output, maybe it's not super clear that this sum happens to be their actual expenditure, because I don't see a dollar sign here anywhere, and unless I actually get to read this query and understand the thought process behind it, the data output results don't specifically tell me that this sum happens to be their total spent. So I can simply say as total spent, and notice I do this directly after whatever column or function result I want to rename, and then I run this, and I get back here in the data output total spent. Now, here is where I really want you to focus, because this is where beginners often make a mistake. Let's imagine that I wanted to clarify on the sum amount. We already know I can do something like this. Having sum amount, and let's have it be greater than 100. And we actually did pretty much this exact same query, and I'm going to remove as total spent. So what am I doing here? I'm doing the exact same thing as before, except after I've done the group by and calculated the sum amount, I'm going to do an additional filtering using having, where sum amount is greater than 100. So I run this, and notice now my sums are all greater than 100. And now I'm going to use, again, my alias to just clarify that as total spent. So I run this, and now I get to see total spent here. Unfortunately, this alias gets assigned at the very end, which means I cannot do this. And this is where beginners try to do this a lot. They'll say having total spent greater than 100. And if they run this, you get back an error. It'll say column total spent does not exist, which at this stage is true. Total spent is only going to exist at the very end at the data output. So because an alias gets assigned at the very end, you cannot use it in something like a where statement or a having clause. Unfortunately, you have to go back and choose the original either column name or the original function. So we'll have to say having some amount greater than 100, and we see back these results. So keep that in mind. These aliases get assigned at the very end, so you can't use them to filter by. So I'm going to show you another example of this. Let's just go ahead and remove group by and having some, and we'll just say amount. We run this. So here are all the customer IDs. Notice there's repeats as well as the amounts. Now let's imagine I wanted to qualify this for amounts greater than $2. Well, I could say from payment, then where amount is greater than 2. So I run this, and now notice I got rid of all those 199 transactions. Now, if I happen to use an alias on amounts, so we'll say as new name, I run this, notice new name is now in the data output. Unfortunately, I cannot do this. I cannot say where new name is greater than 2. If I run this, I get the same error as before, that new name does not exist. So again, just to clarify, these aliases get assigned at the end, and unfortunately, you can't use them in the where clause or the having clause to filter by. Instead, just think of them as being used in the data output. And you'll have to use the original column name if you plan to do any filtering or comparison operations on it. All right, that's it for the as statement. As you can imagine, as we begin to join tables using join statements, it'll become quite useful to be able to assign aliases for clarification. Okay, coming up next, we'll begin discussing joins. I'll see you there. Welcome everyone to this lecture on the inner join. There are several types of joins, and in this lecture, we're going to go through what I think is the simplest join type, which is an inner join. And typically when students are learning about joins in SQL, they always start off with the inner join because it's the easiest to understand. First off, what actually is a join operation? Put simply, joins allow us to combine multiple tables together. Now, the main reason for the different join types is to decide how to deal with information only present in one of the joined tables. So let's begin by imagining a very simple example. Let's say our company is holding a conference for people in the movie rental industry. So before the conference actually starts, we're going to have people register online beforehand. And the registration is simply just providing their name, and we'll keep track of people as they register. And then the actual day of the conference, they're going to come in and log in through an iPad with their name. So after the conference, we end up having these tables. So we have a registrations table as well as a logins table. The respective ID columns indicate what order they registered or logged in on site. So we can see in the registrations column, we have Andrew who registered first, then Bob, then Charlie, then David. And then we have logins with Xavier, Andrew, Yolanda, and Bob. For the sake of simplicity, we're going to assume that in this little small universe, all the first names are unique. So there are not two Andrews, there's not two Bobs. Every person has a unique name. Now, to help you keep track of the different joins, since we're going to be using these example tables throughout this section of the course, keep in mind that the registration names, first letters, go A, B, C, D. And if you take a look at logins, the two outstanding ones that are not in the registrations are Xavier and Yolanda, basically implying that they forgot to register but still showed up the day of the conference. So what does an inner join do? An inner join will result with the set of records that match in both tables. So the situation we have right now is in the registrations, we had Andrew, Bob, and Charlie, and David register for the conference. However, the actual day of the conference, when people were logging in, we only had Andrew and Bob show up that actually registered, and then Xavier and Yolanda, who forgot to register, they came in on site and then logged in. And keep in mind here that it looks like Charlie and David registered, but didn't end up showing up to the conference to log in. So we have that discrepancy there of Xavier and Yolanda in the logins table, and then Charlie and David in the registrations table. So where do we actually have a match in both tables? Well, we have Andrew and Bob. Andrew and Bob are the only ones that both registered and logged in the day of the conference. So an inner join is going to be able to join these tables together for records that are a match in both tables. So when we're talking about an inner join, we're only looking for the set of records that happen to be in both tables. And in this case, that would only be Andrew and Bob. So what's the actual syntax for this? Well, we can say select and then whatever columns you want, but in this case, we'll keep things simple by selecting all columns, and we say select all the columns from table A, and then inner join with table B. And then we provide what we're actually matching on. So match on table A column is equal to table B dot column match. So what does that actually look like in practice? So if we color code this and think of the tables as Venn diagrams, and if you look up SQL joins on Google image search, you'll see a ton of Venn diagrams. So a lot of people like to think of it this way. If we see here that we're selecting from table A, inner joined on table B, where table A column match is equal to table B dot column match. So we're essentially saying grab table A and then grab table B, and because it's an inner join, only grab the rows that happen to be in both table A and table B. And we have to actually join these tables on a particular column, such as the name column that we saw in registrations and logins, because we know the names are unique over this small universe of people. There's only one Andrew, only one Bob, etc. Now, something to keep in mind, especially if an inner join, is notice that this Venn diagram essentially is only filled in the crossover middle. Essentially, stuff that can be found in both of these circles, table A and table B. Because of that, inner join is essentially symmetrical, which means if you select from table A and then inner join table B to look like this, select from table B, inner join on table A, you would get the same result. So getting from table A and then joining on table B is the same as getting from table B and then inner joining on table A. Keep in mind, this is only true for an inner join in this particular case. So switching around the orders here, even switching around the column match order, doesn't really matter for an inner join because it's the same regardless, because this is a symmetrical Venn diagram. So let's actually work through this and what would actually happen in a more realistic situation with the example tables. Here, we're going to say select all the columns from registrations, inner join, logins. So that's essentially saying take registrations table and then perform an inner join with logins, seeing the rows that happen to be in both registrations and logins. And then we have to decide what column we're actually looking at in order to perform this inner join. And in this case, we'll do it on the name. We'll say on registrations dot name, so it's the table name dot and then the column name is equal to the table name dot column name, so logins dot name. And keep in mind, you could swap any of these orders around because it's an inner join, it's symmetrical. It doesn't really matter if we're saying select from registrations, inner join on logins, or select from logins, inner join on registrations. And you can also swap around that on equals sign to be something like on logins.name equals registrations name. Okay, so here we're just generally showing the syntax, and we're looking at that name column. So then we look at, well, where do we have a match in both tables? And that happens to be Andrew and Bob. And so we said select all the columns from these. So that includes the registration ID column as well as the login ID column. So we have these 4 columns, we have the matches, and we join them together to see this result. So this is selecting all the columns from the resulting of registration inner joined with logins on the name column. Okay, and that's it. That's an inner join. Again, an inner join is looking for matches that exist within both tables. And here we're saying select all the columns. Notice, because we said select all the columns, the name column happens to be duplicated or repeated twice because there's both a name in the registrations and the name in the logins. If you wanted to get rid of this duplication, what you can do is actually specify what columns you want. So here I'm saying select registration ID, logins.name, then login ID from registrations, inner join logins on registrations.name equals logins.name. So you might be wondering, why did I have to specify logins.name instead of just saying name? Well, the reason for that is because name existed in both tables. So we had both tables share a column name, which means if I'm selecting something after a join, I should specify what table I'm referring to in regards to the name column. And in this case, it doesn't really matter. I could have said registrations.name or logins.name, but I should be specifying because there's a duplicate name column. In my SQL query, I should be specifying what actual column I'm looking at. Because recall, here we had both the name column from registrations and the name column from logins. So if I only want one of those, because it's duplicated, I'll specify that I'm looking at logins.name column. Remember, again, that table order won't matter in an inner join. And also, if you see just join without the inner, PostgreSQL will treat it as an inner join. Now, I'd highly recommend that you always type out the full inner join, but some people, as they get really used to PostgreSQL, just use the shorthand of join, which defaults to inner join. Okay, let's go ahead and jump to pgadmin and work through a couple of examples. Okay, here we are in pgadmin. Now, if we come over here to schemas under public, under tables, we can see the various columns that are in the tables. So if we take a look at, for example, the customer table, we can expand the columns, and we can see we have the customer ID, and then the associated information with that, such as store ID, first name, last name, email, etc. And we can see in the payment table, we have the payments as well as a specific payment ID and then the customer ID. So what I want to begin exploring is if there was a way I could join the payment table with the customer table in order to get maybe the customer email associated with a specific payment. So for example, I can say, select everything from payments. We'll go ahead and run that. Let's put this on 2 lines together just for readability. So I run this and I can see I have a payment ID and then a customer ID, staff ID, rental ID, amount, etc. Let's go ahead and do the following. We'll say select everything from payment and we'll perform an inner join with the customer table. So this is essentially table A inner joined with table B. And since I'm doing an inner join, I'm only going to get back results where that particular customer happens to be both in the payment table and in the customer table. And now I have to decide what I'm actually going to join them on. So I have to join them on a column that is associated with both the payment table and the customer table. And I can see I have this customer ID column, which essentially uniquely identifies every single customer. So let's go ahead and join it on, and then we'll say payment.customer_ID equal to the customer table dot customer ID. And if we run this, we should get back a lot of columns. So we run this and we can expand on this. And now you'll see I have the payment ID, customer ID, essentially all the information from the original payment table. But if I keep going further, now I see the repeated information based off customer ID, but now it's on the customer table. So I see the store ID, first name, last name, email, address, etc. All right, now let's see how we can select certain columns from each table. If I'm referring to a column that can only be found in one of the tables, then I don't need to specify what table it should come from. Luckily, PostgreSQL is smart enough to understand that if I refer to something such as select the payment ID column, since that's only found in the payment table, I don't need to actually clarify what table it should come from. However, if I'm referring to something like customer underscore ID, that can be found in both tables. So I should clarify what table I'm actually asking the customer ID from. And since I'm asking for payment ID, I should probably link it to the customer ID from the payment table. So I do this by saying payment dot, and then I ask for the customer ID. And then finally, let's go ahead and choose some column that is unique to the customer table. For example, their first name. So we'll simply say something like first underscore name, and let's go ahead and try that out. I'll put this from on a new line here. So I'm selecting the payment ID, which is unique to the payment table, payment.customer ID. Customer ID is not unique to either table, so I clarify what table I'm actually referring to for that column. And then we select first name. First name was unique to the customer table, so I don't need to say customer.firstname. Optionally, you can say customer.firstname and nothing will happen or nothing will change, but it's just easier to say just first name. So let's go ahead and run this and see the results. Notice now I get to see payment ID, customer ID, and first name. So this is the general syntax that we're using for inner join. Notice how the inner join is only going to join customers that are found in both payment and the customer table. Essentially what that means is by providing this inner join, I'm not going to see customers that have never created any sort of payment because I'm only looking for customer IDs that are found in both the payment table and the customer table because of this inner join. So again, general syntax, I select columns from a table, let's say table A, inner join on table B, and then on payment.customer ID equal to customer.customer ID. So table A, the identifying column equal to table B and the same identifying column. Keep in mind, this column could be called something else in the customer table. It could be maybe shortened to just C underscore ID, but as long as they're referring to the same thing, the customer ID, that's okay. Typically, in a well-designed database, these should have the same column name, but keep in mind sometimes the column name will be slightly different in one table than the other, so it's up to you as the SQL query developer to just make sure and double check that it's referring to the same thing. And as I mentioned before, for an inner join, technically these orders don't really matter. I could say from customer inner join with payment, and if I run this, I actually get back the exact same results. And depending on what version of SQL you're running, or PostgreSQL, they may be in a slightly different order. However, keep in mind those results should be exactly the same because we're only looking at the intersection of that Venn diagram, stuff that's both in table A and table B. So it doesn't really matter what order you're looking at it because that Venn diagram is symmetrical. Okay, that's it for the inner join. Again, this is pretty much the simplest join possible, just looking at rows that happen to be in both tables. Thanks, and I'll see you at the next lecture. Welcome everyone to this series of lectures on outer joins. So as I mentioned, there's a few different types of joins, and one of the subsets of these types of joins are outer joins. And there's actually a few different types of outer joins. Outer joins essentially allow us to specify how to deal with values only present in one of the tables being joined. And these are more complex joins than the simpler inner join, which is essentially the default join, where you only grab rows present in both tables. So definitely take your time when trying to understand these outer joins, especially when we start talking about left and right outer joins. So in this series of lectures, we're going to start by talking about full outer joins, which is the simplest outer join, and we'll also add in the clarifying where statements you can add in order to specify what actual rows you want even further. And then we'll go into a lot of detail about the left outer join, which is probably the hardest for beginners to grasp, And then we'll also add in clarifying where statements to subselect rows from a left outer join. Once you understand that, we'll just quickly go over right outer join, since it's essentially the reverse of a left outer join. And if you understand a left outer join, you pretty much already understand a right outer join. It's just the opposite. But let's not get too carried away. Let's begin with the full outer join. So let's start with the full outer join. Now let's review the two example tables from the previous lecture series on inner joins. Recall we have these registrations tables and this logins table, where we have people registering for a conference, and then depending on whether or not they showed up or if they registered, we have them log in on site. Here we have Andrew, Bob, Charlie, and David, or ABCD. They registered. Logins, Andrew and Bob show up. They're present in both tables. However, we have Xavier and Yolanda. They forgot to register, but they still showed up and logged in anyways. Okay, so we know we would join these tables together on the name column. Again, in this little universe, we're going to assume that the name is a unique identifier. There's no such thing as two Andrews or two Bobs in the world. And recall, using that inner join that we learned about previously, we could match Andrew and Bob in both tables. However, keep in mind we have names that only appear in one table, and that is Charlie and David in registrations and Xavier and Yolanda in logins. So let's see how the different outer joins deal with this particular discrepancy. We're first going to take a look at the simplest, which is a full outer join. And this actually might be even easier to understand than an inner join. So an outer join, or a full outer join, just grabs everything. So the syntax is select all the columns from table A, do a full outer join of table B, and then on wherever that column match occurs from table A equal to table B.column match. And it's essentially just grab everything, whether it's present in both tables or present in only one table. Notice that it doesn't really matter again if table B and table A order is switched here, because this is completely symmetrical. So because this Venn diagram is symmetrical, you can switch off the table order because you're going to grab everything anyways. So let's take a look at this. The actual syntax here would be select all the columns from registrations, perform a full outer join on logins on registrations.name equal to logins.name. So let's actually see how SQL thinks about this in the background. First, we're saying grab everything from the registrations table. So I'm going to have to first make this just font-wise a little smaller so we can fit in the results table. And we're going to fill in the results table the way we can think about this. We're saying grab everything from registrations and a full outer join on logins. So we fill in first everything from registrations. Again, we don't really need to worry whether or not they're in table B or table logins because we're grabbing everything anyways. So we fill in with Andrew, Bob, Charlie, and David. And then we're doing a full outer join on logins, so we need to start filling information for where we actually have a name match. And we know we have a name match on Andrew and Bob, and then we fill it in with the corresponding login ID. In this case, it was number 2 and number 4. Now the issue we arise with is that we didn't have a Charlie or David in logins, but we're still asking for everything. So what SQL ends up automatically doing for us is filling this in with null, essentially clarifying to you that there was no value there present. So there was no Charlie or David in the logins column. And since this is a full outer join on logins, we also need to fill in the rest of logins, which was Xavier and Yolanda, and then the corresponding null values for the registrations table because they were only present in the logins table. So this is what it would look like to do a full outer join on these two tables on the name column. We grab everything and then fill in for null values where we only had a row present in one particular table. So this is the easiest outer join to understand because you're essentially just grabbing everything. Now the next thing I want to quickly discuss is qualifying a full outer join with a where statement. And we can do this in order to get rows unique to either table. In other words, rows that are not found in both tables. Essentially, this is the exact opposite of an inner join. Let me show you why. The way this works is we say the following. We'll say select everything from table A with a full outer join on table B on table A.column match is equal to table B.column match. That's what we had last time, and that filled in the entire Venn diagram, including the intersection. However, we're going to add in a where statement to qualify it a little further. And this is going to add in the statement where table A.id column is null or table B.id column is null. So that essentially means that we're looking for the actual values where one of the table's ID columns is null or the other table's ID column is null. Essentially the opposite of an inner join, because this will only grab things that are unique either completely to table A or unique to table B. Keep in mind, notice here I could have switched the order from table A to table B because this is again symmetrical right down the middle. So what does this actually look like in our example? We'll say something like select everything from registrations, a full outer join on logins, on registrations.name equal to logins.name, and then we can specify where registrations dot this registration ID is null or where logins dot login ID is null. So this to show you how this would actually work. This is what we had last time. This is a full outer join. And notice here we have null values for our registration ID and null values for our log ID. Technically, we could have done the checking of null on name as well, but we're just going to use the ID column here. And what we're going to do here is we'll specify grab them where there's only null values for that. So look here, we're going to add in where registrations.regid is null or where logins.logid is null. Essentially, you can think of this as adding in a where statement after you've already done the join. So you're just further filtering. You're going from this full outer join table and then specifying find me where those ID columns are null. And that essentially removes those first two rows, which was the match for Andrew and Bob. And now this is going to show us the results that are unique to only table A or only table B. We no longer have rows that can be found in both tables. Essentially, the exact opposite of an inner join. So let's see a quick example in pgadmin of full outer joins, as well as adding in that qualifier. Okay, here we are at pgadmin. Let's imagine that some new privacy rules have been implemented, and we want to make sure that we don't have any payment information that's not attached to customer, or that we don't have some customer information that isn't attached to any payments. Essentially, we want to make sure that all the payments we have is associated with a current customer, and all the customers we have are associated with some historical payment. We don't want to have some customer ID information for someone that's actually never purchased anything in any of our rental stores. So that's the new privacy update. We're just kind of imagining the situation. So what are we actually going to do here? We can say select everything from payment just to get an idea of what we're working with. We have again this payment ID and this customer ID. And I want to make sure that essentially all the payments here are associated with a current customer, and if I select everything from customer, that these unique customers are associated with some sort of payment. I don't want to have any customer here that hasn't actually made a historical payment. So the way I'm going to do that is I'll say select everything from customer and do a full outer join with payment. And just as before, we're going to say on, we'll say customer dot customer ID equal to payment dot customer ID. So because this is a full outer join, that's just going to take everything and join it together. So essentially, this is every single row found in every single table. So again, it's everything from customer and everything from payment. But recall the new privacy idea that we wanted to implement was to figure out, make sure we don't have any information that's essentially unique to payment, not associated with customer, or unique to customer, where we for some reason have customer information like their email when they've never done a historical payment. So that means I want to perform an additional filter with a where statement. So I want to check where on my customer table that customer ID happens to be null. So we'll say where customer ID is null. We can put that in lowercase. Or where payment ID is null. All lowercase there. So what is this actually saying? It means we're going to fully join the customer table and the payment table where those customer IDs join up. And now I'm going to filter it to attempt to find rows that are either only unique to the customer table, meaning we have information about a customer that's never made a payment, or only unique to the payment table. Notice here how I'm using the payment ID, which is a unique identifier for the payment table. If we keep going over, we can see here every single payment has this unique payment ID. And if I run this, notice I get back empty results, which actually means we're in compliance with this new privacy policy. We don't have any payment information not associated with some customer, and we also, more importantly, don't have any customer's email information, their first name or last name, who has never made a payment. Now, what's another way we could confirm this? Well, I could confirm this by taking a look at the distinct customer IDs in both my customer table and my payment table. So this alone basically tells us that there are no rows that are completely unique. Essentially, there are no customer IDs that are completely unique only to the customer table or only to the payment table. If we have information on a customer, it's because they've done some payment in the past. And we're able to select this with a full outer join and then filtering to make sure that there wasn't anything unique only to one of those tables. And to confirm this, just so we can wrap our head around this idea, let's go ahead and just count the distinct customer IDs from the payment table. So if I run this, there's 599 unique customer IDs or distinct customer IDs in my payment table. And if I take a look at my customer table, refresh this, there is also 599 distinct customer IDs. Now, technically, this doesn't fully answer the previous privacy compliance policy because there could possibly be different ID numbers in different tables. The real way to answer the previous question to make sure there wasn't any customer information that didn't have payment information was using that full outer join and then filtering an additional where with the null statements on those unique identifiers for the customer ID and payment ID. This technically by itself only further validates that last query we did, but doesn't actually fully answer the question. Because technically there could have been maybe customer IDs that were letters in one table that were 599 unique letters or a series of letters, and then the other table could have 599 unique numbers. So keep that in mind. While this does clarify and verify what we did, it doesn't 100% confirm that privacy policy. The only way to do that was using that full outer join with the additional where that we just saw. So we're learning about really powerful tools here, and so far we wouldn't have been able to answer those sort of questions without learning about the different join capabilities. Okay, so coming up next, we're going to learn about a left outer join, which is typically the join that usually trips up beginners, but we're going to take it slow, and once you really get the hang of it, especially with those Venn diagrams, it shouldn't be too bad. Thanks, and I'll see you at the next lecture. Welcome everyone to this lecture on the left outer join, otherwise known simply as just a left join. A left outer join results in the set of records that are in the left table. If there is no match with the right table, then those results are null. Later on, we will learn how to add where statements to further modify a left outer join. So, what does a left outer join actually look like? Here, notice that our Venn diagram is no longer symmetrical, which means the order will actually matter. Here we're saying select everything from table A and do a left outer join on table B. The left-hand table is the first table referred to in that from statement. So that's why table A there is seen on the left. So we're saying select everything from table A left outer join on table B. On table A.columnMatch is equal to table B.columnMatch. So notice we're essentially just grabbing information from table A where there's either exclusive to table A or table A has a match with something in table B. If something is only found in table B, then it is not going to be returned in the query. And again, recall that a left outer join can be shortened to just left join in SQL syntax. So it doesn't matter if you use left join or left outer join. Now, because of this asymmetry, this is where beginning students often get confused. Previously, everything we saw, it was symmetrical in that Venn diagram, which means the table order didn't matter. When it comes to a left outer join or a left join, the order does matter because we have to actually specify what the left table is going to be. So notice here we're saying table A, which means we're going to grab things that are exclusive to table A or can be found in both table A and table B. We are not going to be returning anything exclusive to table B. So again, not returning anything exclusive to table B. So let's explore a left outer join with our two example tables. Here we have registrations and logins. So what we're going to say here is say select everything from registrations, perform a left outer join on logins on registrations.name equal to logins.name. And what does this actually look like? Well, it's going to return the following. Recall that we're going to grab everything from the registrations table, and if there happens to be a match with the logins table, we'll go ahead and return it. If there is no match, we're still going to grab that information from the left-hand table, which is from registrations, but because there's nothing in table B for it, we're going to fill it in with null. Notice that things that were exclusive to the right-hand table, that is the logins table or table B, that was Xavier and Yolanda, we don't actually see them in this result of the left outer join. Previously, when we saw a full outer join, we did see those results. But now, because we're specifying a left outer join, we only see things based on that left-hand registrations table. It either belongs to both tables or only to registrations. If it only belonged to logins, we don't see it returned here. So again, everything from registrations ends up showing up in this left outer join, which is why it's critical to remember that table order does matter in the SQL query syntax when it comes to a left outer join or a left join. Now we can further qualify this with a where statement to get rows unique only to the left table. So for instance, what if we only wanted entries unique to table A? Those are rows found in table A and not found in table B. So we're essentially just grabbing rows unique to table A, not found in this other table. So the way we do that is by saying the following. We're going to again select from table A, do a left outer join on table B, specify the column to match on, and then we're going to say where table B is null. Because if table B is null, that means the resulting rows would only be unique to table A. So recall this was our previous query. This is just the left outer join, registrations and logins. And what we're going to do here is if we take a look at the login ID column, we notice we have those null values. So what we're going to say here is go ahead and grab where logins.logid is null. And because the logins ID, that is from the right-hand table or table B, was null, this answers the question that these particular rows are exclusive to the left-hand table or the registrations table. So Charlie and David can only be found in the registrations table. They cannot be found in the logins table. So this is a left outer join with an additional specification to only grab tables unique to the left-hand table, that is table A or registrations in this example. So definitely take your time with these and feel free to watch this video a couple more times. Sometimes it takes students just a couple of times of watching this video to truly get the understanding of a left outer join. This is the most complicated join because it is a non-symmetrical join. So let's see some examples of a left outer join in pgadmin. If this is still a little fuzzy to you, I would highly recommend that you go back, watch this from the beginning, just let things cement theoretically, and then come with us and join some SQL queries in pgadmin. Okay, I'm going to hop over to pgadmin now. All right, the two tables we're going to be exploring for this particular example is the film table, which I can just select everything first from the film table so we can get an idea of what's in it. So I run this, we have a film ID, which is a unique identifier per film, the film's title, a description, release year, language ID, rental duration, etc. So we have that information here, basically information about the film. The other table we'll be taking a look at is the inventory table. So the inventory table, if we run this, it basically has a unique inventory ID, and then the film ID, which matches up with the film table, and then the store ID. So essentially this says that we have film ID 1 located in store ID 1. And then we have another repeat, essentially a duplicate copy of film ID 1, also in store ID 1. So this essentially begins to imply that we have multiple copies of films in certain stores, and we also have the possibility of films only being located in one of our two stores. So let's start exploring this. Keep in mind, each row in the film table may have 0 or many rows in the inventory table. So for example, we have film ID 1 is currently in inventory both in store ID 1 and store ID 2. So we have lots of copies of film ID 1 in both stores. So what I'm going to do is the following. We'll say select film.filmID, film.title, and then inventory ID. So the reason I don't need to specify inventory ID of a table is because it's unique to the inventory table. However, film ID can be found in the film table. And in fact, title is actually unique to the film table, so I don't need to mention that as a table as well. So we have select film ID, title, and inventory ID. And this is where we're going to do our join. We'll say select from film, left, and you can say either left outer join or just left join. Those are syntax-wise the same thing. And we're going to say inventory on inventory.filmID equal to film.filmID. We run this and note what we're having here. It's basically telling us the film ID, the title that belongs to that film, and then its specific inventory ID. And if I wanted to, I could expand on this by asking for also the store ID. I could run this again, and I can see we have Academy Dinosaur, multiple copies in store 1, as well as multiple copies in store 2. So that is a left join, essentially showing us the left joining of film on inventory. So what does that actually mean? Because film is on the left-hand side, I'm only going to see rows that are either in just the film table or in both film and inventory. Right now, I am not seeing any films where they happen to only be in inventory for some reason, but not have some sort of title attached. So because some rows in the film table do not have corresponding rows in the inventory table, we would see that the values of the inventory ID are null. So there's lots of rows here, but eventually as you scroll down, you may find something to be null. So what I'm going to do here is show you that. We're going to say where the inventory dot film ID. Note here how I have to specify the table for film ID because it is found in both tables. And I'm going to say is null. I'm going to run that. And often you also see null be in all caps. So keep in mind, you can also just do all caps null, run that, and it looks the same. It's up to you whichever manner you prefer. But what is this actually showing us? This is showing us a film ID, a unique identifier for the film, as well as the title, and is showing you that we don't have this in inventory, which means essentially if someone comes up to us and they ask, hi, where or what store can I find Alice Fantasia in? We can do this query and it basically answers it that we don't actually have Alice Fantasia in our inventory. In fact, we don't have any of these movies currently either in our inventory or in any store. We have information on them. I can tell you the release date or the actors in them, etc. from the film table and maybe doing other joins. But unfortunately right now, we don't have them in inventory. And so here you can begin to see the use case for a left outer join, essentially showing us films that we have information about, but that are not in our inventory because we're specifically checking where that inventory film ID is null. Okay, so that's it for this lecture on the left join. Keep in mind, we're going to get more practice on this with your challenge questions, so feel free to review this lecture as many times as necessary. Thanks, and I'll see you at the next lecture. Welcome everyone to this lecture on right joins. A right join is essentially the exact same thing as a left join or left outer join, except that the tables are switched. And often Beginners get confused when first starting to learn SQL, especially when they hit that left outer join, which is the most difficult join to learn about because it's asymmetrical, and then suddenly they're introduced to this concept of a right join. And students often get confused because it seems like the right join is a completely different thing, but the reason I don't want to dwell on it too much is because a right join is essentially the exact same thing as a left join, except you just switch the tables around. So this would be the exact same thing as switching the table order in a left outer join. And in fact, you can pretty much go on just using a left join for two tables and just switching up the order of the tables in order to satisfy whatever need you have. So it really depends on how you think about the tables and what order they come in your mind, whether table A is on the left, table B is on the right, or if table B is on the left and table A is on the right. So I want to quickly show you some examples through a Venn diagram. So a right outer join, notice this looks a lot like a left outer join, except it's just flipped along the axes. So we're saying select everything from table A right outer join on table B, where table A has a column match equal to table B. So what this is saying is essentially the exact reverse of a left join. And what this is saying is return back rows that can be found either exclusively in table B or in both table B and table A. And do not return back rows that are exclusively only found in table A. Notice how this would have been the exact same thing as a left join had we just switched around the table order. Okay, so again, this is pretty much the exact same thing as a left join, except you're switching those tables around. And you could actually get back these same results by doing a left join and selecting first from table B with a left join on table A. So keep in mind, really the right outer join is just to help you keep the same tables in the same order in your mind of table A is on the left and table B is on the right, but switching up the results you get. And keep in mind, you can do either right outer join or right join. They both work fine. And just like we could with a left outer join, you can also add a clarifying where statement to say something like where table A.id is null, in order to clarify that you only want tables that can be found exclusively in table B and are not found in table A. Okay, so it's really up to you and how you have the tables organized, quote unquote, in your mind when it comes to choosing a left versus a right join. Since depending on the table order you specify in the join, you could perform duplicate joins with either method. So if two tables can be joined and you can get results with a left outer join, you should also be able to get the exact same results with a right outer join or right join by switching the table order and playing around with that table ordering, or playing around with any table ordering in the where results, depending on the exact query you're doing. So really take your time to understand the left outer join extremely well, and then if you want, you can begin to use the right join if the moment calls for it, or if you want, you can always just stick to left join and switch around the table order there. Okay, so again, hopefully if you understand left outer join well enough, you can see how right outer join is really the brother or sister of left join. You're just kind of flipping that and just keeping the table order the same in the query itself, but flipping the results around. And if you wanted to, you could just flip the tables in the query in order to keep the left join call and not have to switch to a right join call. So take your time with these two slides. This pretty much just answers the question of what a right join is. And if these slides are confusing to you, then you need to go back and really take your time to review the left join and left outer join. Because once you understand that really well, then these two slides should be very clear in the fact that it's just a left join with the tables flipped. Okay, thanks, and I will see you at the next lecture. Welcome back, everyone, to this lecture on unions. The union operator is used to combine the result set of two or more select statements. The way I like to think about a union versus the joins we've already learned is that it basically just serves to directly concatenate two results together, essentially just pasting the results of two select statements right on top of each other. The syntax is simply the following. You have your first select statement, and then you have a union with another select statement. Something to keep in mind is that these should be logical and they should match up in a way that you can stack the results right on top of another. Let's go through a simple example. So let's imagine we have these two example tables, and what we're doing is we're organizing the sales per year per quarter. So I have one table with my first quarter sales for the year 2021, where David sold 100 amount and Claire sold 50. Then I have another table storing my results from the second quarter. Again, David now has sold 200 and Claire has now sold 100. If I actually want to put together the information from these two tables in order to get kind of total results or see every single time a amount was sold for the first half of the year, I can't really use the typical joins that we're already familiar with. Instead, what I should be doing is just pasting one of these on top of the other, and this is perfect for a union. So all we need to do is say select everything from the first sales quarter, union with select everything from the second sales quarter. And what it's going to do is just grab the results from the first query and then paste them right on top of the second query. And as you can imagine, if you wanted to, you could have multiple union calls just pasting together these different results. And what you can also do is, for example, if you wanted it to be ordered or sorted by the name, you can just add an order by call after this to order it by the name. Okay, so as far as the DVD rental database goes, there's not really a good use case for the union call. So instead, we'll explore union calls later on in the course with another database. Thanks, and I'll see you at the next lecture. Welcome back, everyone, to this lecture where we're going to challenge you and your new skills on the join concepts. It's just going to be two quick problems, but one of them is going to try to have you do something that we didn't exactly see in the lectures. So let's start with the first challenge, which is the easier of the two. So let's imagine that a California sales tax law has changed, and we need to alert our customers to this through email. So the question is, what are the emails of the customers who live in California? Okay, here are the expected results. So you should be able to view 9 customers that live in California, and these are the emails. You may not get them in this exact order depending on how you actually solve this problem. Coming up are some hints. So, as you probably saw from the previous picture, you're going to need to take a look at the district column. For whatever reason, the actual database labels the California state as a district. So take a look at the district column. That's what you're going to be using, and you're going to need to use the address and customer tables. Okay, let's go ahead and take a look at the solution. So here's the solution, and in fact, I'm going to code this out in pgadmin just so we can work through the logic a little bit. Let's head over to pgadmin. Okay, here I am in pgadmin. What I'm going to do is first explore the two tables we're working with. So I know I have the customer table. I'll take a look at it. And what I need to do is figure out what am I going to join the customer information on to the address table. And you should notice right away that the customers have an address ID, and they don't really have any other information on their address. And if we take a look at the address table, so let's select everything from address, we have this unique address ID that then has all the information on that address. And specifically what we're looking for is information about this particular district. So that's the California district that later we're going to be filtering on. So since we're going to be doing an inner join, because I essentially just want where the tables match up of a customer living in California, what I can do is say select everything from address, inner join with customer on address dot address ID is equal to that customer's address ID. So if I just run this, I should get back a whole bunch of columns. So notice now I essentially have this kind of mega table, so to speak, returned, where it's just all the address information for that particular customer because I'm joining it by the address ID. So now I get to see the address, address to, district, and so on. And if I keep scrolling all the way over, now I get to see the customer information, their first name, last name, email, and so on. And notice here, address ID is repeated. It shows up twice, and that's because there was 2 address ID columns, one from the address table and then one from the customer table. So in theory, I can actually begin filtering off the results of this. So now I can say where district is equal to California. And if I run this, Notice now I get back all those same columns, but now it's only for the districts that have California. And if I expand on this a little bit and scroll down, you should see there's essentially only 9 results. And recall, really the information I was interested in was the email. So I can say district email columns from this result, and I get back these results here. Now, a really common student question is, what if I wanted to say from customer inner join on address? That's totally okay too, since we're really doing an inner join and we're interested where I have entries for both the customer and the address. It's not really helpful if I don't have a customer that exists there because I'm not going to be able to have an email for them. So you could technically switch out address and customer here. So I just want to show you that. So let's say I say select from customer, inner join on address. Notice here the order doesn't matter because this is an inner join. So if I run this exact same thing, I get back the exact same results. So for an inner join, this table order doesn't matter. This join column order doesn't really matter either because it's the same inner join. It's that center of that Venn diagram where they're actually connecting. And you didn't have to do this in as many steps. Hopefully you're able to just kind of do this in a few steps without having to select all the columns from the table. All right, so that's the logic for building out this first challenge. Now let's go ahead and go back to the second challenge, which is a bit harder. All right, your second challenge is the following situation. A customer walks into the store and they're a huge fan of this actor, Nick Wahlberg, and they want to know which movies has Nick Wahlberg been in. So your task is to basically get a list of all the movies Nick Wahlberg has been in. So let's take a look at the expected results. Here are the expected results. There should be 25 movies. You can get them in any order you want, but really what I want you to do here is just stop the video right here and don't move on to the hints and solution. Instead, really push yourself to see if you're able to return the results as shown here. Not just the titles, but also the first name and last name linked to the title to confirm Nick Wahlberg is in this movie. And the reason I really want you to push yourself here is because you're going to have to do something that we didn't exactly show in the lecture, but you should be able to look up online through a Stack Overflow search, a quick Google search, or even the PostgreSQL documentation. And this is really where you get to expand your skill set and become good at looking up information online instead of just becoming a master of memorizing everything. In fact, it's a much more valuable skill to be able to look things up for new situations because you're going to always be encountering new situations. So I really encourage you to just pause the video and try your hardest to see if you can duplicate or replicate this expected result table and get back the 25 movies that Nick Wahlberg has been in. Okay, so I hope you gave it your best shot. If you're still a little stuck, what we're going to do is give you some hints. So here are the hints. You're actually going to need to do 2 joins in a row to do this in a single query. If you actually already got the results, but you did it throughout multiple queries, that's okay too, but I would highly encourage you to try to do this as a single SQL query call. And in order to do that, you actually need to do 2 joins in a row. And I highly encourage you to search the online documentation or a simple Google search to see how this is done. Or if you want, you can also search the Q&A forums. This question has been answered before of how to do multiple joins in a row. The tables you should be using are the actor table, the film table, and the film actor table. Okay, so again, this is something we didn't exactly show in the lecture because we want you to be able to feel comfortable pushing yourself beyond your limits of what you already know and discover new information online by yourself. Okay, so those are the hints. And finally, let's go over the solution. So this is what the solution should look like as an example. And we're essentially going to select title, first name, last name, and we're going to be doing 2 joins. So let's go ahead and jump to pgadmin so we can walk through a little bit of the logic of what's happening here. Okay, here I am in pgadmin again. Let's go ahead and explore the 3 tables we're going to be working with. And that is the film table. And if I run this, note that the film table has the title information that I'm looking for. And it also has this film ID. Unfortunately, the film table itself has no direct information about what actors are in that film. And if I take a look at the actor table and run that, This has the information of the first name and last name. I can actually see Nick Wahlberg has the actor ID of 2, so he shows up second in that list, and it has the actor ID. What I need to do is figure out the go-between or connection between the film table and the actor table, which this database actually has for us in the form of the film_actor table. This film actor table directly connects the actor ID to the film ID. So what I need to do are two sets of joins, essentially film to film actor ID, and then film actor ID joined to film results to the actor. And then I can do any filtering I want based off the first name and last name. Let's go ahead and check this out. There's lots of different ways you could do this depending on the ordering you think of, but let's start off by connecting the actor to the film actor table. So let's say select everything from actor, inner join with this film actor table on actor.actor ID is equal to film actor.actor ID. So if I just run this and see the results here, now I have the information of my actors, first name and last name and their actor ID. And if I scroll down, I now have this film ID, which is exactly what I need to join this now with the film table. So this is where I need to do yet another inner join, which hopefully you're able to figure out through a little bit of Google searching. And if not, that's okay. That's what this lecture is for. So then we're going to inner join these results with film on, and this is where we have to think, what are we actually joining here? Well, I'm looking for the join between the film actor's result for film ID with the film ID. So I'm going to say film actor dot film ID equal to film dot film ID. Run this, and now I get back even more results with the actor ID, first name, last update, actor ID, film ID, and then the title. So what am I actually interested in here? I'm interested in the title and the first name and last name. So let's just select those columns. Title, first name, last name. Run that. So now I see the titles and then the actors that are in that title. Perfect. So what's next? I just need to filter out where the first name is equal to Nick and the last name is equal to Wahlberg. So what we're going to do here is say where first name equal to Nick and last name equal to Wahlberg. And make sure you take note of the capitalization. So we run this, and now I get to see the titles that are associated with the actor Nick Wahlberg. If I scroll down, I should see those 25 titles. Okay, so that's the logic here. You're going to take your first results from actor, join on the film actor on the actor ID, then join those results with film based off the film ID. And technically, you could have switched these orders around since we're essentially looking at the interconnection or these inner joins, so the orders don't really matter. Okay, that's it for your challenges. Hopefully, you were able to really push yourself on this second challenge problem. I'll see you at the next lecture.